Okay. Again, good to see you all. Hope you all had a great weekend and that you're doing well and had you have a good start to the week. Of course, our final is a week from Thursday on the official YCP schedule. It's 8 to 10 a.m. What I'll probably do is have it open as early as 7:30 just to give you a little bit of extra time. Not that you'll necessarily need it, but it's not bad to have a little bit of extra time. I can't really, and I don't really want to go to the right. So beyond 10 o'clock, because the final schedule has exams starting at 10:15 and those kind of things. And I want to respect those times. Okay. So more to follow on the final. Let's take a look at our map check. So here we are today. It's the 5th of May. We're going to talk about total quality management and lean today. On Thursday, we're going to do our Kahoot class photo, see how that goes. So I'll just do a snapshot off my screen of all of you and then post that to Canvas and Instagram and all that stuff just for kind of tradition. And then we'll go into our final prep. We'll probably do some Kahoot as part of that. So if you're watching this off a mobile device or just you probably want to have some sort of mobile device handy as well as your computer or whatever you're watching this on so that you can participate. And there'll be some extra credit up for grabs as part of that. Before I finish talking about the prep, please, if you've got things you'd like to go over again, the earlier you send those to me, the better. That way I can make sure that we cover those on Thursday. On Friday, I'll have your class interaction and participation assessments posted. And on the topic of assessment, everything is updated, posted to this point. So the only thing remaining is class interaction and participation and the final. So if you haven't looked at Canvas lately, I would encourage you to do so, understand, quote, where you stand. And if you have any questions on that, please get with me again earlier than later. Let's talk about reading day reps a little bit. Again, reading day rep is your chance to get a block of time toward the last minute before you go into your final prep. And so I offer blocks of time on Friday, 8 May. Any of this would be during Zoom or via Zoom. And all the times are available right now with the exception of 1 to 1:30. So if you want some time, just email me and tell me what time you'd like and we'll set it up. So today we're going to go over, we're already recording today. Again, I talked about please send your questions on things you'd like to cover on Thursday. I don't have a hit list up, so I apologize for that. What is going to be on the final will be the 6-pack, so that's probabilistic inventory, statistical process control charts, X, R, P, and C. We're going to have a little bit from MRP on there. I understand that MRP is time consuming, so we're not going to have a lot, but we'll have things like bill of materials, how to establish gross requirements, and potentially how to establish a timeline for a product to be done. And we might have a little bit, just a tiny little bit of MRP, but I'll go over that again on Thursday. And then the other thing that'll be on the final is what we talk about today. So we're going to talk really conceptually today. There's very little math involved. There is a point where I'm going to ask you for participation, so please watch for that. Don't just tune out or anything. But today will be largely conceptual when we talk about TQM and lean and its relationship to operations management. But before I get into all this, are there any questions out there on anything that I have or haven't covered, big or small? Okay, everybody ready to rock? Let's get on to it. All right, so today we're going to talk about total quality management. and lean. Not this kind of lean with Michael Jackson, although I always thought it was cool until I found out he has magnetic shoes. But I still think it's pretty cool anyway. And Total Recall is not one of the best Schwarzenegger movies, but it's like Schwarzenegger. It's always pretty good. Anyway, here's what we're going to talk about today. We'll first talk about TQM, Total Quality Management, talk about the purpose, the 7 tools of quality, and then we'll spend the most time on the fishbone because for a number of reasons. I'll get to that when we get there. And then we'll break and we'll talk about lean, overall purpose, a little bit of history, how we determine profit under a lean philosophy. And then what's not here on the agenda, the impact of lean on operations and production. And then specifically to where we've been recently, the impact of lean on inventory management. And just to kind of show you a little bit what's behind the curtain when we talk about lean and inventory management, it really runs kind of counter to like an EOQ model and some of the places we've been. It doesn't mean that everything we've talked about is null and void and that it doesn't matter. It's very situational and all depends on your approach. So we'll talk about that when we get there. But before all that, just a tiny, tiny, tiny shameless plug for this material. Not necessarily me, but the supply chain department, and not even the supply chain department. So the short of it is, and I know that all of you are very far along in your college careers, and I think that's awesome. But if you like any of the things that we're going to talk about today, or anything we've done in this course. And when I say like, you go, man, I really like this material and I look forward to this and it's not work to me and those kind of things. We have other courses. We have a whole course on TQM that I'm actually teaching in the fall. We have a whole course on lean, which is taught by my colleague, Dr. Greisler. We have a whole course on Six Sigma, which we're not going to talk about so much today, but is kind of part of this. And then we have other courses, logistics management, modeling and simulation, those kind of things. So I just say, hey, if you really like this stuff, why stop? It's kind of like getting one piece of pizza. Why stop at one? Get more. We have majors in supply chain. I know all of you are far along, but it's never too late. I've seen people switch at the beginning of their junior year without difficulty to supply chain. But we also have minors. We have certificates. We have student clubs. We have all sorts of cool things. So if you like this stuff at all, please either get hold of me or one of the supply chain majors in the course. We have 3 or 4 of those warriors, and we can get you hooked up with more fun. Okay. And if you don't like it, that's cool too. I understand. All right. So when we talk about total quality management, there's really a lot to it. And I'm not going to attempt to teach that course in half a day today. That's not the point of that at all. I think the point of it is to give you a little bit of an understanding about TQM so that when you continue on in your careers and you work for a company or you work for a business and you hear people talk about TQM, you can say, hey, I know what that means. And you can identify what that means to you and your role and how you can contribute. TQM, let me tell you a little kind of side story, which is, again, you all know I spent 28 years in the Army. I've probably said that at the risk of sounding like a broken record, but I worked this one place, my last job in the Army, and part of my job was to be on a board that met every month. And it was a board for the installation. And on the installation, there were a number of agencies that would come to this board and they would talk about activities they had done, so on and so forth. And inevitably, somebody would say, well, we had this event and we thought it was a very quality event. And I would always cringe when I would hear this because I knew the questions that were coming. And so the inevitable question was, well, why do you say it was a quality event? And you would get some nebulous kind of half attempt definition of quality. All right. So that brings us back to the point. While the purpose of TQM is to improve quality at every level, it really is null and void if you don't define what quality is. And there's a number of ways you can define what quality is. You could define that quality is only a certain amount of errors. You could define that quality is a certain tensile strength in your product, or a fiber count, or megahertz, or a processing speed. So there's a number of ways you could define what quality is beyond just, hey, some kind of nebulous, it was a good time kind of thing, which leads to my next point. If you define what quality is, then you probably have some way of measuring it, and you should continue to measure it. Okay. So, for example, we have ways, of measuring quality at your college in terms of the quality of our education. One of the measurements in the past has been student observations, which we're not doing this semester because it's a little bit different. But that is a measurement of quality. It's not the only measurement, but it's a measurement of quality that we really take to heart. And so then finally, if you define and measure quality, then what do you do with something that isn't meeting the standards of quality? How do you ensure quality both proactively and reactively? So that those three words aren't necessarily mine, but that's how I would boil down TQM, is to not just saying, oh, we've got a quality organization, we have a quality team, we have a quality process, but how do you define, measure, and ensure that quality consistently? And the reason why this topic, why does TQ, why did the supply chain and operations guys teach this? Why not some other discipline within business? Well, it certainly isn't, supply chain doesn't have a monopoly on this. I think the reason why it kind of falls into our lap nicely is because we have a lot of flows going on in what we do, specifically product, money, and information. Okay. So when things are moving, it makes a lot more sense to define, measure, and ensure quality. But it doesn't really matter what you do. If you're in accounting, if you're in information management technology, if you're in some other field, I think you could take this idea and apply it to what you do, the same way that you could apply operations management principles. So that's the overall purpose. What we're going to talk about today are some of the tools of quality, which I think is news you can use, so to speak. So rather than just kind of big concepts, you can take this, you can go, I recognize those 7 tools. We worked with some of those. And you could instantly go out and use any one of these tools in your daily life, if not some other course. So that's where we're going to spend some time today. And so these are the 7 tools of quality. And over here, I've got this thing of the Punisher. And the reason I like this image is because the Punisher's got all his stuff set up. It's nice and organized, but just like any other tool, not every tool is the best tool for a specific job. So the idea is that he's got this rifle up there that he pulls down when he needs it, but then he puts it back. And he's got some weird helmet over here that he pulls down when he needs that, and then he puts it back. So not all tools are created equally. So if we go over these, there's 6 on this slide, and then the 7th one is the one where we're going to work together very briefly. So some of these we've messed with in this course. So you kind of already know what they are and how to use them. A flow chart we haven't worked with so much. We kind of did when we did the clock simulation and got into that. We started drawing process flows, and when we worked with capacity management. So I think the thing about a flow chart as it applies to quality is, where do you build in checks on quality? Okay. Like at decisive points where if something doesn't happen, something in the process is going to just fall apart. I think TQM, the conventional wisdom, is that everyone is responsible for quality. And like we saw on the clock simulation, if you have one station that's responsible for quality, and it kind of gives the impression to other people that, oh, I can just kind of slough through the work because Chris will catch that when it gets to him. And that's really a faulty management approach. Really, you should empower everyone and hold everyone accountable for quality. Another tool of quality is the checklist with my favorite Ice Cube. And the checklist to me is good. What I don't really like the checklist is that it's it it you can get people into this idea where they kind of check everything. And I kind of feel like if you're checking everything, you're going to miss something. Not everything matters in a process. Some things matter more than others, and that kind of offends people sometimes. But when you go to check an aircraft before it takes off, you check a lot of things, but you don't check everything. You check things like the radar, the altimeter, the landing gear, the engines, those types of things, but you're not going to check every single thing on that aircraft. If you have checklists like that, then you're going to cripple people. You're going to overwhelm them. They're going to lose sight of what's really important. So a checklist is a tool. There's not that there's anything wrong with it. To me, it could be unfocused sometimes. And I've seen that sometimes. We have a checklist like this long, and in reality, no one's doing it. Okay, because it's just too long. All right. So that's an example of that. Moving along, a scatter plot. Well, essentially, we did scatter plots with regression. The purpose of a scatter plot is we want to take two variables and we want to examine the potential relationship between the two. To me, the connection to quality is where if something is going up and we think something up goes up at the same time, or if something goes down and it goes down at the same time, and these things have a relationship and an impact on quality. So let me give you an example. To me, an obvious one, we probably wouldn't even want to do a scatter plot, only just to kind of confirm what we're looking at, is the number of hours of sleep someone gets and the number of errors that occur. All right. So I would think that would be the opposite of this scatter plot that's on the screen. That would be a negative correlation. So the more hours of sleep I get, the less errors I make. Whether I'm driving a bus, I'm flying an aircraft, I'm on an assembly line, I'm teaching a class. All right. So that might be something that if we think that is going on, it might be good to capture some data because the errors are an enemy to quality. Something that might be the opposite of that is what about pay? What if we pay our workers more? Do they make less errors or do they do more? Do they produce more kind of thing? That would be like this scatter plot that's on the screen. So as we pay them more, do they produce more? um, that might be an interesting thing to do a scatter plot for because we want that quality production. So that's another tool, quality. A histogram, I think you all have probably messed with the histogram at one point or another. At some point, histograms we use with categorical variables. So let's say that I'm running a business, or like I experienced many times in the Army, and what we do at your college is we go through a process called accreditation. And this means an outside organization comes in and inspects us across like 25 areas. With your college, it might be something they might inspect on how we do on teaching, administration, um, and in either also some non kind of education types of things like maintenance of the facility and things like that. And so you might come out of that kind of inspection with categories of how you came out on the inspection, like excellent, very good, good, satisfactory, and then poor kind of thing. Well, we know with categorical variables, you can't really break that up. If something's good, it's either good or it's satisfactory. There's kind of no in between. And that's the kind of thing a histogram leads itself towards. And so if I got inspected, I would say, okay, I have some areas that are excellent. I have an equal amount that are unsatisfactory, and then I have some in between. So you start to drill down and say, what are those areas that are unsatisfactory? What do I need to do there to make them satisfactory? In some instances, if you get inspected as unsatisfactory, it might shut your business down. Food sanitation is a primary example of this. Other places that have sanitation standards, veterinarian clinics, hospitals, those kind of things. So I think a histogram is good. And all of these, when we talk about tools of quality, it's another way of looking at this. And I know many of you are athletes, so I think this will resonate. It's like a scoreboard. And so as a leader or a manager, as a manager, you might be, both have contributions to the scoreboard, but a histogram kind of tells you how are we doing. And so if you look like something like this, of course, Pareto is kind of different, but if you had a lot of areas over here on the left that were unsatisfactory, you don't look so good. So histogram, I think even more than the other ones, kind of gives you an idea on what is happening and helps you break it down. And of course, we know that if we're working with numerical variables, a histogram eventually just becomes a line. But we see that more in Six Sigma and those kind of things. Pareto, I really like a lot because I have found in my experience that, and it's not a hard and fast rule, but Pareto came out of the idea of this 80-20 idea. It's not a rule. The minute we say it's a rule, I talked to a class one time and somebody said, well, this is an 80-20, and it's not that everything is 80-20. It's more of a fluffy kind of thing where you have these sayings like 80% of accidents are caused by 20% of reasons. No seatbelt, texting on the phone, those kind of things. A long time when I was in the Army, I did find that 80% of the time, there were 20% of the people that did the work, that got the job done. And the other 80% were kind of hanging out, contributing lesser, but there's 20 people that were really the ones, working kind of thing. And a Pareto to me works really well when you are looking at something and maybe you give a survey, and like, so these could be complaints. So we talked about, when we talked about process control charts, we talked about running the hotel. So if we survey the people staying at the hotel saying, hey, what didn't you like about our hotel? This gives us an idea of where to start. So if A is that continental breakfast that people really don't like, and E is the channels we're offering on cable, we know that we probably shouldn't run out and try to solve the cable thing and expect people, to make a big impact. What we need to attack is the continental breakfast, if that's what this leftmost category is. So I really like the Pareto chart because I see the Pareto chart as a series of drilling. So, for example, if A was the continental breakfast, maybe we want to launch another survey that asks people, what didn't you like about the continental breakfast? And then that could result in a follow-on Pareto. It's like those Russian dolls. You kind of open one and one gets smaller and you keep on opening. Maybe not the best example. But the point is, the Pareto, you can keep drilling and kind of really, not kind of, really getting after what is the root cause of our problem. And then you can prioritize assets and resources towards solving that problem. So, if you have a budget or you're the one divvying out a budget, and again, in the Army, we dealt with why, I forget what it was. I think what causes people to get hurt during peacetime. And this column right here was drinking and driving, unfortunately. And so if E is like forklift safety, well, you shouldn't go spend all your budget on forklift safety, you know, programs and training, because that's not what's getting people hurt. And so we would make decisions on, you know, how do we spend our budget? What kind of additional training? What kind of additional programs do we need? So, and then finally, control chart. I got our friend Janet Jackson up here, but y'all are well acquainted with control charts and their contributions to quality. When something is out of control, when a process is out of control, that's when we want to investigate further and see what we can do to get things back in control, which takes us into the seventh tool of quality, which isn't necessarily the best, but I think bridges well from where we've been recently with control charts. And that is the fishbone diagram. Now, the fishbone diagram, I think, is multi-purpose in a couple ways. So out here on the end, we either have the thing that we're trying to accomplish or that we're trying to prevent. Okay, so that's why it's written problem or goal. All right, and we're going to do an example here in a second. So, for example, we can say that we want to have 99% pass inspection of an item that we're producing, or the problem is maybe the items are faulty and defective. So we can phrase this either way, but this is kind of like our gold at the end of the rainbow out here on the end. And what the fishbone does is it takes things and puts them into categories. So instead of us just going, we know we have problems that can occur and not prioritizing, the fishbone helps us say, okay, let's put a framework towards understanding the barriers to our success and therefore quality. Now, a little bit of trivia, and I know that I know Dr. Greisler calls some of these things different. It's kind of like the 4 P's in marketing. You turn around and someone says there's a 5th P and a 6th P. Pretty soon there's going to be pepperoni. It's going to be one of the P's of marketing. But this actually used to be the 4 M's, was not necessarily the hard and fast rule, but a guideline towards understanding this. And then now it's the 6 M's, and it's still not the 6 M's because we've changed some of the M's. But I think this model you'll get a lot of mileage off of this framework. So I'm just going to talk this clockwise. I'm going to start right up here with an M that people more often than not kind of forget, which is measurement. So when we talk about measurement, we want to think about how we are measuring or how we've defined quality and what we need to check in terms of that measurement. So I'll give you a quick example. If we're making boxes, that's our production, then probably what's involved in our boxes, our box production, is the scale. So we've got, in terms of measurement, we've got to check the scale every so often to make sure that the scale is accurate and it's giving us accurate readings. Because if we're loading boxes on a truck and we're either not weighing those boxes or we're weighing those boxes on a faulty scale, we're going to have false shipments. And we're eventually not going to know, very quickly, we're not going to know what we're sending out. Okay. A clock could be another measurement process. Let's say our goal is to select the fastest runners off the lacrosse team. Well, we better have a stopwatch that's working. Okay, so those are items in measurement. People, this actually used to be man until we realized that that was kind of outdated, so we made it people. All right, people are you, are me. Okay, so when we think about people, we want to think about, does Jasmine have the training that she needs to do this job? Has Gilbert had sufficient rest? And those kind of things. All right. Has Ethan had experience doing this before? Maybe he had the training, but this is his first day on the job, those kind of things. Um, Environment is another one of those kind of hidden M's. I know Dr. Greisler calls this Mother Nature. All right. But we want to think about, are there things in the environment that, um, if left undiscussed, could compromise our operation? So think about the food industry. If it's really humid and we don't have temperature control, that could be affecting our environment. Especially again in the military, if we move from one environment to another one. I've been in situations where we moved from January snow on the ground to 114-degree weather. So there's some, our environmental impacts on things. Those kind of things have big impact on, can people fly? Can people, operate as long? Those kind of things. So even though we have an own category for people, we can have environmental impact on people. We can have environmental impact on machines. We can have environmental impact on any one of these categories. Moving down here to the bottom, when we talk about materials, here we're talking about all the inputs, especially if we're in production. So let's say we have machines, we're cutting steel. So steel would be one of the materials. Is the steel the grade that it's supposed to be? Have we inspected that? Maybe we have to put oil into the machines. Maybe we have to put blueprints into the machines. So have we inspected that to make sure we have the right blueprint to make the right cut of steel? Again, the idea is not to list everything on here because then it just becomes a mess, but to list the critical things that are going to either help or hinder us accomplishing what's down here. Um, Methods. So, method is, again, one of these things. I think the best example of method is when we're cooking. And in that analogy, it would be the recipe. Okay. So do I have the approved method? Is it there, or are people just kind of rolling their own kind of thing? Um, and then finally, machines. So in our steel cutting example, when was the last time we serviced our machines, checked our machines, that kind of thing? Okay. So what we're going to do now is we're going to help out a good friend of mine because he's been operating for a while and he never went to operations management. Arguably he doesn't need to, but he would like us to build a fishbone for the Batmobile. Because every night he goes out, he patrols Gotham City, and he has this expectation that the Batmobile should be able to go from 0 to 60 in less than 2 seconds, which is faster than any car on the planet, to include the Dodge Hellcat. The Demon is the latest version. All right. So what we're going to do right now is I'm going to fire up my handy dandy pen, and we are going to build a fishbone for the Batman and the Batmobile. All right. So here we go. Get this out of the way. All right. So out here, our goal is 0 to 60 in less than 2 seconds. And if you get stuck, don't worry. I'll help you. And we know we have the 6 M's we can use to get us started. So what do you think, Ethan Locker? What's one of these things and what might go under it?
So like measurement, like the first one.
Yeah. Okay, so what's something under the category of measurement that we would want to check in order to accomplish this?
Maybe you can see how fast the Batmobile gets up to 60, like in general.
Okay, and we'd probably want the speedometer, right?
Yeah, speedometer.
So we want to check and make sure that there's nothing wrong with his speedometer, so that when we put the foot on the gas, we can get an accurate reading of how fast the Batmobile is going. Okay, so that's a good one for measurement. Let's move on. Chris, what do you think about one of these other ones?
If you go straight below, it would be machine.
Okay.
And in the case of the machine, would that not be the Batmobile itself or the
Yeah.
parts that are used to like make the Batmobile better so it can hit 0 to 60 in under 2 seconds?
Yeah. So the machine is largely the Batmobile itself. Now, Chris also talked about materials. So probably critical parts. Ellie, what's another example? You love these kind of problems, I know. What's another example of materials for this situation?
I don't know, maybe the tires.
Yeah. Want to check the tires so that they're not worn out, because if they're worn out, they're not going to be able to grip the pavement, especially if it's raining, which it seems like it always is in Gotham. And that's going to compromise this right here. Okay, super. Luke, what do you think? Grab one of these other open spots.
Wouldn't manpower be one of them?
Okay. So we'll call that people.
Yeah.
All right. All right. So what would go under people, do you think?
Just the people working on the car, I guess, the factory workers or the R&D team. Just people working in the factory.
Okay. All right. So if he had like, so Alfred often does a lot of his work. So does Alfred know what he's doing? Kind of thing. Myra, what's another example? What's something else we could put under people, you think?
I would put like the person operating the car, maybe
Who is that?
Batman.
Yeah. So things like, has Batman had enough sleep, which he notoriously does not have enough sleep. Probably gets like 2 hours, 2 to 3 hours a night. So those kind of things. Okay, super. So we got measurement, we got people, which is kind of mankind, although I don't even like writing that because it sounds bad. We have materials, we have machine. What else? Let's see. Hannah, what do you think should go over here? Josh, what do you think should go over here?
Environment.
Okay. So what's something we might want to check about the environment to ensure that this goal goes the way we want it to?
Um, making sure that the roads are that he's driving on are like able to be operated on.
Yeah. So maybe a route plan. Aviators do this. I mean, to say aviators do this all the time is a complete understatement. Aviators live by the flight plan. And so, same kind of thing what Josh is talking about. We do an analysis of the roads and see, is it raining a lot? Is it snowing? Is the Batmobile going to be able to traffic those roads? What's the impact on that? And then, Allie, what do you think down here? What do you think should go here?
That's going to be your method section.
Okay. So, what might go under method towards, and when it comes to the Batmobile?
Mhm. Is that kind of going to be like how it's going to happen?
Yeah. So like how he drives.
Right.
Yeah. Very good. So the recipe kind of how he drives. Now, or you can imagine, you don't just jump into a race car and drive this. Probably any one of us can do it once, but can you do it night after night and not get hurt doing it? So, how is Batman been, what method is he going to use? It kind of goes a little bit into training. And I guess you could say that at some point, some of these depend on each other. So if the roads are bad, that might affect the method. And if he hasn't had that much sleep, that might affect the method too. So I wouldn't suggest that any of these are necessarily in a stovepipe, but it gets us going. Again, the fishbone is a framework towards understanding what might compromise our goal and kind of putting all that into a pot and boiling it and then seeing what comes out. Okay. Kylie, Tim, anything y'all have to add on this that I've missed in terms of fishbone?
I think it's good. I think you pretty much touched up on it pretty well.
Okay. Kylie, anything?
I think it looks good.
All right. Little happy face down here on Batman. All right. I asked those folks because they've had this course on TQM. And again, the point is not to make this into the kitchen sink. Here's one more example on a fishbone. Come on, computer. This one's on making burgers. And I know what some of you are thinking, there's such a thing as a bad hamburger. Well, maybe not at your age, but later on in life, there is such a thing as a bad hamburger. I like to say if there's such a thing as a bad hamburger, then you're not hungry enough. But anyway, I digress. So this is one of these things. Another one example, machines, lots of cooking issues. Again, what do we see first and foremost with the method? Recipe comes up super fast. Okay, materials. Lots of hay is stuff hygienic, is stuff perished. Measurements, incorrect quantity of spices. That's an interesting one. If you've ever cooked, maybe you've made the mistake where you used a tablespoon instead of a teaspoon, so that can throw things off. If you've ever done that, maybe you use too much salt or you use too much sugar, that kind of stuff. And then environment. All right, so one more example on the fishbone. All right, moving on to lean. So again, lean and TQM, what's the relationship? Well, they're not the same. In terms of the overall idea of improving quality, they're certainly kind of related, but I think from that point on, they kind of have different ways of going about it. Here's the overall purpose of lean, which is three things which potentially run opposing to each other if we don't watch out. We want to increase value to the customer while reducing waste and preserving quality. We could reduce cost. In my opinion, that might compromise quality. So that's where it kind of goes in that old phrase, you can have it cheap and fast, but you can't necessarily have a quality. And so lean is saying, hey, we want to do these three things. We want to increase value by reducing waste and potentially reducing cost, which is different than making things cheaply. Okay. And that difference is preserving the quality to the customer. So a little brief history about lean is this man right here, Taichi Ono. And Taichi Ono, in my opinion, is the godfather of lean. He's really the impetus behind lean. He essentially came up with lean procedures out of the ashes of post-World War II Japan. So after being bombed twice by the United States in Nagasaki and Hiroshima, there's an old phrase that says, necessity is the mother of invention. Meaning that Taichi Ono saw how Ford was operating in the United States and he worked for a guy named Toyota that made cars. And he told Toyota, he said, we cannot operate the way Ford is operating. We'll never make it. We'll be out of business. The country we're in is in this Great Depression. So Toyota probably said, well, how are we going to do things? And Ono said, watch me. So Ono, in my opinion, really attacked a lot of sacred cows. And I don't know how familiar you are with that expression. A sacred cow is kind of a belief that people rarely challenge, even though it probably needs to be challenged. And so you have the sacred cow. Oh, well, that's the way things have always been, kind of thing. And Ono said, Ono really didn't care that that's the way they'd always been. With Ford in the United States was in a different place. We'd already had our Great Depression almost a decade earlier. World War II had brought this country out of that Great Depression. So now Japan was in the opposite situation where they were in a depression. So Ono said, for us to produce, we have to do a number of things on the production side and stay in business. We got to empower workers. One of the things that still holds true with Toyota today is that any worker on the assembly line who sees something going wrong can stop production. And that just amazes me, coming from a culture where that didn't really happen in the military. You had to have some rank to stop things. Otherwise, you kind of had to just live with them. Another thing that Ono was really an innovator and a pioneer of was multifunctional machines. So Ford had these huge single function machines that could do kind of one trick pony. Ono said, there's no way we can afford that, and there's no way that we need that. We need to be able to, number 3, produce in small batches. We can't just have mountains and mountains of the same car, because people will not be buying them that fast. Ford was, I love this quote by Ford. To me, it really embodies the situation at the time when he said this. Ford said, you can have any color car you want as long as it's black. And to me, that means that really exemplified the industrial age, where we just produced in mass quantities. And the reason he said you can have any color you want, except as long as it's black, is because he didn't have to give people choices, because he really didn't have a competitor, and everybody wanted a car. Ono was not in that situation, so he had to produce in small batches, and that's what he could do by making multifunctional machines. And also through empowering workers, he could get to problems faster, because anybody would say, hey, stop, we need to do this better. And they would implement those solutions. And Ono was really the man. We, the United States, still follow lean today. Many companies embrace lean. And it's really from the things that he and others, but largely he started. And when I researched a little bit about Ono, I would have thought that he was a micromanager and he was like a real tight ass and a kind of a pain to work for. I think I found quite the opposite, that people who worked for him loved him. They felt like he was almost his father, their father. And he would employ people for Toyota for like 35 years because he would pay them right. And he would really take care of them. So what I would like you to think about, at least through the rest of today, and of course now until we finish the exam. I know once the exam is over, you're going to be like, summer, yeah, and I don't blame you. But ask yourself the question, when you see something, what would Ono say? So when you see something, would Ono say, oh, like that's a great idea? Or no, that's a terrible idea? And this will make more sense in the next couple of slides. To give you a little preview on the exam, I have 10 questions that are true, false, where I give you a statement and you've got to evaluate each statement and answer O, which would be, yeah, Ono would be in favor of this, or no, he would not be in favor of this at all. So the first thing here is how to define profit. And I actually have a slide where I'm going to do this again, because I think just like some math, when we see it all at once, it's very deceiving. So I'm just going to go straight to my little impromptu board here. And again, I've never said I'm the smartest guy in the world, so you may be going, duh, I get all this. But when I saw Dr. Greisler do this the very first time, I did not get it. And I was kind of embarrassed to tell him that I did not get it. And I don't think I got it until about 6 months later when he gave me a book and I read the book and I got it. So I'm just saying that because I think it's very deceiving and I want you all to get it. So the non-lean way of determining profit, I'm just going to call this non-lean. And it could be pre-Ono, it could be post-Ono, because there's companies today that don't necessarily follow a lean philosophy. This is determining profit. Okay, is they start kind of over here, I'll just say number one, by determining what something is going to cost. And when I say something that's going to cost, so let's say we're a manufacturer of cars and we say, okay, it's going to cost us $500 to make next month's worth of cars. I know these figures are bogus, but just roll with me. And so then the next thing that happens is they determine how much profit they want to make over that. So if we're making cars, it's going to cost us $500. Let's say that we want to make 100 profit over that. Okay. And so then the third thing we do is we say, okay, well, if we want to make 100 profit, we need to charge our customer, and that is called price. So if I'm making cars and I have a retailer that comes and buys these cars from me, then I'm going to add together what it costs me to make these cars and how much profit I want to make on top of that. And that's the price that I'm going to charge to whoever's buying them. So if Trevor's buying these cars from me, I'm going to say, hey, man, it's going to cost you $600. Okay, that's the price that I'm charging him. So you got to be careful about what cost is. Cost is what it costs us to make something. And price is what we charge the people that are paying us for it at the end of the day. So this is the non kind of lean way of doing that. And so the bottom line is this price is not fixed. Meaning that let's say things change. And whether it's inflation or whatever, I'm just looking for another color here that'll show up. So let's say my costs go up to $600 and I still want to make that 100. So by this method, I'm going to just add those two together and I'm going to do what I call pass that price off to my customer. I'm going to pass that off on them, that increase. Okay, see how this went up? So I'm just going to pass that increase on to them. So, Trevor comes to me and he gets ready to pay me and I say, hey, it's 700 today. And he goes, well, it was 600 yesterday. And I go, yeah, I know, but my costs have gone up. So you got to eat that cost. You got to eat that increase. Now, I would never talk to a customer that way. And I'm painting the example kind of simply. Where'd my board go? But that's kind of the non-lean way of doing it. And I fully understood. So the way that I came into this was Dr. Greisler took my class and myself down to York Corrugating. And there's a guy working down there named Brad Miller who said that he goes, we can't do this with our customers because our customers are repeat customers. They've been with us for years. So when we try to pass, because steel went up because of tariffs on steel, so Brad's costs went up. And when Brad tried to pass that on to his customers pushed back and said, there's no way. Why are you increasing our prices? We've been with you for years and years and years. You should be giving us a discount because we've stayed with you. And so Ono was in the same boat. Ono said, if we do this to our customers, they're going to leave. So the lean way actually starts over here with fixing the price. And when I say fix, I've never done this kind of work, so I'm kind of talking like a poser. But when we say fixing it, it's like dropping a cement post in the ground. Boom. It doesn't move. You know, when we're doing construction, we put the cement post in the ground, we cement it in, and it doesn't move because it's a pillar. So we first determine what the price is. Okay, that's the first thing that we do. And then we determine what it costs us to make. Now, this equation up here is the same as this equation down here. It's just under this philosophy, under lean, we subtract the cost from our fixed price. All right, so we first determine what we're going to charge the customer, and then we subtract what it's going to cost us to make the item. And if there's anything left over, that's our profit. And you might go, I don't see the difference. Well, check it out. Let's use these same numbers. If this is 600, that's my first set of numbers, and it costs us 500, then we'll make 100. But if costs increase, I can't change that number. And that's the whole point. It's fixed. Not fixed like rigged, fixed like immovable. So here, where I could jack it up, I can't do that here. That 600 is 600. Like Brad's customer, I want that 600 to actually be less. Okay, so under this model, if my costs go up, I don't make profit. And you might say, well, how could Ono survive how can anybody survive under lean? Because under lean, this forces you in this kind of situation, and even when you're not, to continually reduce that. Because that's the only, it forces you into a corner where you can't just pass on price increases to the customer, because this is going to be 600 all day long. If anything, it's going to get less. So if that's that, then you have to figure out how to drive that down. And again, when you look at the purpose of lean, it doesn't mean produce cheaply. All right. In value chain, people want to say that all the time. Oh, so lower cost means cheap. No, that's not what that means. Lower cost means lower cost. And lean means lower cost with the same quality, if not improved quality. So please, make sure that when you look at this material and you reflect on this material later, that you understand, not like I did. I just I said, I get it. And I didn't get it. And I failed a whole bunch of people because I didn't get help understanding this. Okay. So please make sure you don't do that. Don't do as I did. All right. And that you understand what this all means. That's one of, I think, Ona's greatest contributions is saying, hey, the only way we're going to make profit is we have to reduce internal cost. And there's a number of ways we can do that. So when you look at this slide, I know it's been a while, but I want you to think back to our work on the clock simulation. Okay. So, and this is really a production oriented slide. So when we just run down here, when we think about how initially when we did the clock simulation, we were producing off of a set production schedule where we're just pushing things into the system. You think about capacity management. When you just push things into the system, some queue, that's the second part, along the way. Remember when we did it with Gilbert, Kylie, and I forget who was on the end. I think it was Hannah. So we pushed things into the system. Gilbert could handle them. He passed them to Kylie, and Kylie quickly had that queue build up. That's when we push things into the system. But then we learned if we want the system to even flow, we're going to pull things in, often regulated by that bottleneck. And even if we don't have a bottleneck, even if all stations could process through at the same time, we did that through line balancing. When we did the clock simulation, we would want things to move at an even rate. So, for example, everything moves to the right every 30 seconds, that kind of thing. And these two go hand in hand. So, when we push things into the system, we create waste because there's buildup. We stress workers out, and usually that also contributes to defects. Had we done that to Kylie over time, we all agreed that Kylie would have rushed work and potentially made more errors, which is wasteful because somebody has to fix those errors. If we move at a constant rate, the chances are less that Kylie will make errors, and so we won't have to rework anything. Motion is almost kind of a martial arts kind of thing. And a lot of you are athletes. So when you throw that lacrosse ball or when you hit that baseball or when you pitch that baseball, both intuitively and through coaching that there's some motion that you don't want to have. It's like serving a tennis ball. You see people do this with the minimum amount of motion. And I learned at a later age that swinging a baseball wasn't about strength. There's really probably very little correlation between bench press and swinging, the ability to hit a baseball very far. But I think more that's in tune with hitting a baseball far is minimizing and getting rid of all that wasteful excess motion. Okay. And you see martial artists do this. Bruce Lee was famous for this. He had a 1-inch punch where he could knock people across the room with just this 1-inch punch. And it was his ability to channel all of his effort at this one place. It's not a coincidence that Bruce Lee obviously was from the Far East, and so was Ono. It's very much of a minimum for a maximum kind of effort thing. So in the clock simulation, we saw people having to go from one side of the room to the next and things that were kind of not arranged in a way that would make sense. Ono would watch people on the shop floor and he would say, "Why is your workbench way over there on the other side of the factory? Because you spend more time walking from here going over there." He would also watch how people would drill and he would say, why don't you just, he'd talk to them about their movement. So that kind of takes us through motion and transportation. And I have down here conveyor versus forklift because initially in a clock simulation, it's set up for more of a forklift type of operation. But what we saw was that the clocks were more of a conveyor where we had constant movement. So it would make more sense to just put things on a conveyor because we have very much of repetitious movement there. We also saw in a clock simulation that we had a kitting station. Again, I know it's been a while ago, but we had a whole station where people would put parts into containers just for someone to pull out those parts. All right. And so by eliminating the kitting station, we eliminated overwork. We also eliminated the inspection. We had that inspection station that didn't really fix anything. They just inspected it and passed it on to people to fix. We changed all that to a quality station where people could both inspect and rework at the same time. So with this slide, I really want you to think back to the clock simulation and draw examples from that. And I know it's been a while, but also think about places where you've seen that suffer from this overwork, redundancy, and unnecessary movement kind of thing. And you might have seen this in your personal lives, especially if you have a big cleanup project, you're like cleaning up the garage, things like that. There's ways you can work efficiently and ways you can work non-efficiently that really go into these kind of 7 wastes. A little trivia note, Ono's quoted for saying, hey, I never came up with the 7 wastes. He's often quoted as the 7 wastes, and he actually said, I didn't come up with that. I just was, kind of thing. Let's talk about inventory real quick. And so this is a classic slide on, and I'm just actually going to draw it. So you've kind of got it there for the visual. And so the whole idea is that inventory, unnecessary inventory. I don't think Ono would say that inventory is completely unnecessary. I think Ono would say, hey, you have to have certain levels of inventory. What Ono would challenge was excessive inventory. So inventory that's not managed. So let's just say this is an inventory level that's really, really high. Okay, and so the whole idea is if this is unnecessarily high, it's going to mask all sorts of problems that we have. So let's say that Ethan is a manufacturer and Luke is his supplier, but Luke is late all the time. So I'm just going to call this supplier late, which is on the previous slide. Well, so when Luke is late with supplies and Ethan can't manufacture based on those supplies, what's going to happen over time is Ethan's going to keep his inventory level high. So when Luke is late, he's just going to draw raw materials from his inventory level and keep going. Well, the problem with that is the problem of Luke being late never gets addressed. So Ono would say, if you keep your inventory level low, not necessarily 0, so this is high and this is low, Ono would say, if you keep it low enough, Luke's, and this is nothing against Luke, but Luke's lateness will be exposed. You see how we can see that? And Ono would say, as long as your problems are masked, you'll never be able to fix them. But if you force yourself to see them, then you have no choice but to fix them. So in this case, Ethan can't draw raw materials to keep going because he's dependent on Luke. So we have to address what is making Luke late. We might replace Luke. We might give Luke some more resources. There's a number of things we could do. You could also do it on the other end where we have, let's say Ethan makes a lot of defects. So Emily comes to pick up from Ethan his finished goods. And so when she shows up, Ethan starts to load the truck, but he's got 6 items that are defective. Well, he just pulls out 6 items from inventory and it masks the problem. So this is defects. And again, Ono would say, you're never going to solve this problem because you can't see it with a high inventory level. If you keep your inventory low, Emily comes to pick up. Ethan's like, hey, I got to short you 6 items today. Emily's like, what the heck? Okay. So at least it forces Ethan to deal with his defect problem. And those are just 2 examples. But if you go back to that, again, the idea is not that inventory is evil. That's kind of an exaggeration. I think Ono would say, hey, you're not going to take inventory down to 0. But I am talking about this unnecessarily high level of inventory. And, places like Harley Davidson, Motorola, that have very certain demand, which is a key note here. You're not going to, during these times of coronavirus, this is probably not the time to practice a whole lot of lean because demand is so uncertain. kicking off a war, me deploying to Haiti for 75 days, probably not the time to practice lean. But Harley Davidson pre-COVID, Motorola pre-COVID, these organizations that have a really good handle on what their demand is, they are practicing lean all over the place because by now if they're not getting after each one of these problems, they are losing money big time, which is another reason why Ono would say you can't do that. You've got to lower your inventory long enough or low enough so that all your problems are exposed. And then just real quickly, 2 more slides, and then we'll call it a day. I'm not going to go through the 5 S's, but this is really kind of an inventory and a production thing where Ono essentially was like, hey, if you can't see your operation, you can't see the problems and you can't fix it. All right. So remember during the clock simulation, we kind of reorganized and tried to make flow move as smoothly as possible. Here's some simple examples. This is a safety board, which is very common in the Army. You need these safety items. So the beauty about this is that A, it's there when you need it. And then B, you can inspect it very quickly. And a lot of tool boards and things like that are set up the same way so that you can inventory your items very quickly and then inspect them. And this is some home gym kind of stuff. And then multifunctionality versus flexibility. This goes back to Ono's philosophy on having machines that can do more than one thing, but then differentiating that to redundancy. So the difference here, and the big analogy I make is that the power rack, all of these items on the right-hand side, it's not that Ono was a big workout guy. It's just an analogy. All of these items over here, for the most part, are single purpose. This bar holder, pretty single purpose item. The squat rack, pretty, I mean, maybe can do 3 or 4 things on it, but not a whole lot. This plate holder, so on and so forth. But what we did here on the left-hand side is we created a multifunctional workspace. And when you think about it, you look at the small amount of workspace required, but the disproportional amount of capability. And so that was really what Ono was all about, was how do we get multifunctionality out of a small workspace? And that will be the key to us staying, really surviving and producing. I just want to make one last point. This is different than having backups. Okay. So Ono was notorious for, he would go to people and say, why do you have 5 drills? You only use 1. Well, just in case the one drill fails, I want to have a backup drill. And Ono would say, quit doing that. Fix the drill. So either buy a new brand of drill or maintain the drill more often, but there's no need for 4 additional drills. So what I've just described is unnecessary redundancy, and that is different from multifunctionality. Okay, Ono, big proponent of multifunctional capabilities in terms of production, not a big proponent of unnecessary redundancy. Okay, because he would say that's wasteful and that's contributing to waste. And with waste, we're not going to be able to do the things we want to do. Okay, so lots of material here. We will review some of this on Thursday. I have one slide that kind of summarizes all this. Questions on anything we've talked about? Okay. So the main things I want you to think about are probably this slide here in terms of when we think about production. What would Ono say if we said, hey, produce in large batches? He would say, that sounds pretty wasteful to me. And then here, what he would say about unnecessarily high inventory levels. And usually inventory is high because we either A, are masking some sort of problem in our process, consciously or unconsciously, or B, because we're not certain of demand. Now, if we're not certain of demand, we probably shouldn't be practicing lean anyway. But if we're pretty certain about our demand, then we shouldn't have a high inventory level. I've seen places around York that do. And I was with many folks like you. Actually, I was with some of you when I did. And we all kind of had the same expression of, well, that doesn't really seem to make sense. Okay, so that is 2 minutes over. I apologize for that. Appreciate your patience. I will stay on until y'all clear the call. With that, if I don't talk to you, I will see you on Thursday. Have a great week.
See ya.
Professor,
Yes.
I was gonna say a good example for the inventory for the lean would be Tesla. Like they're kind of crazy where they have like no cars in stock. So you pretty much have to like personalize your own online, then you order it and then they build it for you.
Yeah.
And then they deliver it like 2 to 3 months later.
Yeah. Cool. I didn't know that. Are they
Yeah.
actually doing that now?
Yeah.
Hmm.
You
Are
can't
those-
go to a dealership and just find like a Tesla dealership.
Yeah. Yeah. And they probably like it that way too.
Yeah.
Okay. Well, that's cool. That's a great example.
Mhm.
All right. So I'll just pick a number kind of thing. What's up, Kyle? How are you?
Oh, I didn't realize. I thought the conversation was still going.
Oh, no.
I'm good though. Yeah.
So did I
I'll keep
cover
it.
lean? Did I do it justice?
Yeah, I thought you did well. I did zone out a little during the fishbone thing because I kind of like knowing the back of my hand at this point, but I meant to add on one thing with the fishbone. Like, I guess the main point of it is just to find the root cause of something.
Yeah. Yep.
Utilize that in Six Sigma a lot.
Yeah. Yeah. And I've seen that, where again, it's like I worked for a guy one time and he said, I want you to do this and I want you to do that. I said, well, what's the priority? He said, there is no priority. Everything's important.
Yeah.
I said, well, if everything is important, then nothing is important.
Hmm.
It's
definitely like integration of all the different charts together. Like you can't really just use one too.
Yeah. So,
Yeah.
All right.
All right.
Cool.
Thursday.
All right. Take care.
You too.
Professor, I just had a question about grading on Canvas.
Okay. Let me just stop the recording loop.